welcome from my side as well here to our little testing workshop. I guess we can fairly agree that creating the right process model and getting process models right is a tough task to do. Testing those models can be an even harder task, actually. And in fact, we hear it from our customers from time to time, and we hear it from our consultants when they do on-site projects and workshops, that testing complex processes rapidly becomes a very tedious and repetitive task. That's a fairly negative statement when it comes to process testing, so we came to ask ourselves, why is it that people tend to feel this way about process testing? And just a second, thanks. So we talked to our customers, we looked into the code they write when they test, and we actually identified 3 things in the code that supports the statement and makes the statement. People tend to copy and paste a lot of stuff in order to, for example, set up similar test cases for different branches. Also, they use a lot of the low-level engine API that we provide with Camunda BPM Runtime. For example, using the services, using queries, using specific methods from those services for fetching tasks, for completing tasks, and it's a very repetitive and verbose way of using the engine. And the third thing that we discover very often is a very tight coupling of tests to more parts of the process model than actually necessary. So we will see in a minute why this is, and this tight coupling often leads to process tests that break very fast as soon as the models change. And we will see how to solve all those issues in a couple of minutes. Whoa, it's a bit windy in here. So we try to sit together and come up with a model in order to investigate all those things, all those points, and all the points that people find complex and tedious to test. And this is what we came up with. You don't have to read every of those activities. We're going through it pretty quick to get an overview of what we're trying to fuse into a model here. Overall, this process defines organizing a visit to a sports event with your friends. So it consists of something like a user task to pick the event, for example. We have something informing different peer groups depending on the location of the event, for example. It also includes an external task that helps us with reserving seats up front for the whole group, for example. So you can attach an external worker to do this for you. We also include some events in here with the help of the event-based gateway in order to, for example, wait for answers if the group wants to join the event or declines it or doesn't answer in time. So if they don't answer or decline, we might also cancel the whole process using a service task, for example, here in an asynchronous continuation context, as well as some non-interrupting timers, for example, to check if the seats are still available by the time we want to confirm them. And if they're not, we're using a terminate end event here in this case to terminate the whole process, for example. If everything went fine and we confirmed all of the seats, we're using a very complex planning process we call a call activity here, which helps us planning the ride to the event, for example. And then the happy path of our process is basically done. We also included event subprocesses here in order to react to some of the things you don't know when they will happen exactly. They might happen at any point in your process, but you still want to react to them. In this case, for example, let's say the whole event is canceled from the outside due to, I don't know, bad weather conditions, for example. So you want to react to it, and depending on if you already confirmed the seats or did not, you want to have a different result, so maybe cancel the whole process with a terminate end event again. So trying to play around with escalation and signal events here. So we have an overall model that allows us to test a lot of very complex concepts that you could introduce into your model. In the remainder of this talk, we will, of course, not be able to look into every of those aspects because that would be clearly just too much. So we're going to focus on 2 things. But first of all, rest assured, all of the stuff is tested, like the whole process is covered with tests in our lovely project. If you have been here before, Tassilo already mentioned the CamundaCon GitHub repository here, so you can find the process testing repository where the model is in there, where the tests are in, so all aspects of this model are covered. So in the remainder of this talk, we're going to focus on two parts here. The first one being external tasks. This is one of the most trending topics at Camunda in the last couple of months due to microservice architecture and everything like that. And we're also going to look into call activities because their concept is rather, well, it's not that easy to grasp and it's even harder to test usually. So since we don't need all of the other aspects to make it a bit easier to follow the model and what we're going to test, I'd say we simplify this a bit for the talk, so we remove the event subprocesses because we're not going to look into them right now. Also, some of the derived paths we don't need for the talk in order to make clear what we're trying to show here. So let's remove those, and if we compact this a bit, this is the model that we're going to see in the remainder of the talk. It's a bit easier to grasp, still has a lot of complex things in it, and we are going to use that in order to see how test code is written right now and how we could improve this, for example, with BPM Assert. In order to have a proper setup and to have everyone on board, yes, pun intended, this is the setup class for a test. So we run this in a JUnit test class, have the deployment annotation at a class level here to have all our processes deployed for all our test methods and test cases. And also we're going to use the process engine rule that Camunda BPM provides for your testing environment. So this makes sure that an engine is run up, is spin up, and we have all the services available so we can use all the API we need. And with this, I'd say we start looking at how people nowadays, and in a lot of code that we looked at, test external tasks. So first of all, let's assume this is our test case method encapsulating testing that if we pass our external task in a model, we move on to the event-based gateway. It's a fairly easy task, but actually right now you need a lot of code for it to do such a thing. So first of all, what people tend to do in their test cases is fetch all the services they're going to need throughout all the test method. Sometimes this is already extracted into the setup method, but still you have to have the setup method in the class for every process model that you want to test. So it's kind of a repetitive task to always spin up all the services and always get them before your tests. What people then, of course, often do is start a process instance. And what they use for it is the lovely start process instance by key method. What it actually does is it creates a process instance, it also creates a token, and it places the token on the start event of the process. So right now, if we have our token on the start event, we are forced, in this case, we want to test our external task, we are forced to move our process forward to this external task, so we have to drive the model first, before we can assert that driving the model past the external task works as we expected. So what we have to do in this case is we have to somehow find a task, which turns out has to be done by a query somehow. Then you have to call the service again using a complete method, but not putting the task in there, but rather the ID of it, so you have to know that you have to do it. And if you want to put in variables that might be necessary to drive your model, for example, past our information service tasks, you also have to provide variables. And if you're lucky, you know that there is a variables class that does it for you pretty nicely already. If you're unlucky, you're using all those lovely hash maps that all of us very much love to put in values and then hand it over to the complete task. So now that we have driven the model forward, we can assert that we're actually waiting at our specific reserve seeds task, so our external task, which means we have to use this lovely get active activity IDs method, which returns a set, and then you can have a set assertion that somehow makes sure only this one activity is in the set of active activities, which is kind of confusing, a very verbose way to test that you're at the point that you want to test. So now that we're at the point, we also need to make sure that we have an external task that we could actually test. So again, we are using some other service, the external task service in this case, creating a query again, making sure there's only one external task present right now, and then we can fetch it with the query. And all of this code just made sure that we can finally drive the model past the external task and then test that it works as we expected. So in order to drive our model past the external task, what we have to do is use the external task service again, use the lovely fetch and lock method, which you have to provide with a lot of internal stuff that you have to know. You have to provide a worker, you have to provide how many tasks you want to lock, you have to provide a topic, you have to provide a duration for how long it has to be locked. So you need to make sure you put in all the right parameters to finally get a locked task list. And then you can assert that you only have one of those tasks in this list, and then you can fetch the task from this list and make sure you also lock the right task. So by comparing the IDs of the locked task and the task, external task of the model. So there is a very much stuff that you have to know technically in order to get it right here. You can then finally do the stuff you actually wanted to do, which is completing the external task. By using, again, the list of tasks, getting the first one and its ID, again, putting in the worker that you used in order to lock it. So that's a very lot of stuff that you have to know to do. And then we have our lovely variables again here. So again, if you're lucky, you use the variables class. If not, you're using the hash maps again. And all of this just in order to assert that now, again, our lovely active activity IDs method just hands over the wait on answers activity, which is the event-based gateway. So this is all the code you had to write to just make sure you can get past an external task in your model. That's actually a lot of code. So you made it from the start event over the user task, over to the external task. And that's actually a lot of code to write just to make sure that this kind of basic thing works. And that's fairly why we kind of clearly see why this becomes a very tedious and repetitive task. Just imagine yourself doing some more complex things or even have parallel external tasks right now. So you may need to make sure you fetch the right ones and don't fetch the wrong ones. Maybe they have the same topics. So this is going to get ugly very quickly. And we're going to see how this can be improved a lot by using the right tools. And one of those tools being BPM Assert that we're going to look at today. And in case you haven't come across it, this is the repository of it. It was created as a community extension, so created by Martin Schimak. And we're very proud of it because it has been used by a lot of customers already. And a lot of people know about it, but some people don't know how to use it right or how to use it correctly. And we're going to have a look at how we do it. So looking at the external tasks again, this is the method that we just created. The first thing that, as I said, a lot of people do is get all the services. Just don't do it. BPM Assert provides you with it. All the code that does this, you can fairly remove from your code, so just remove it. Because what BPM Assert provides is static access methods to all the services. So you don't have to care about it. You have the runtime service as a static method. You can just access it and use it. What we then did is start a process instance. And as I said, it does three things. It's creating the process instance. It's also creating a token and placing it on a start event. Actually, what we really want to do is we just want to create a process instance and then, if possible, place the token on the external task and not on a start event, because then we could just start right away with testing the external task. If there only would be an API to do that. Does anyone here in the audience know which API we could use for it? Niall? Yeah. So we remove all of that code because we don't want to drive the model. But what we want to use is process instance modification API. It's a fairly long name, but it's very short to use. So instead of starting a process instance right away and placing the token on a start event, what we're going to do is we create a process instance by key. Now we have a modification API, and we can instruct it to just start directly before the activity that we want to test. In this case, reserve seats the external task. And that's actually it. So it doesn't matter where your activity in the process is. You just use the modification API, instruct it to start there, and then test from that point. So over to the assertion part and making sure that we have the right point. Actually, it would not be necessary to test it anyways because we just used an API that guarantees that we actually arrive there. But for the sake of showing it, we can easily make this a bit more readable and a bit more understandable. Instead of using such a complex thing like getting a set back and then make an assertion on a set, what we could do is we can write an assertion on a specific part of the process. In this case, the process instance. So we're removing this code, we're making an assertion on a process instance This is provided by BPM Assert. It allows us to now assert stuff on the process instance. For example, that it is waiting at exactly our reserve seats activity. So it's way more readable than before, it's way less technical than before, and way less error prone. So, and it reads, it's just human readable. So you can assert that the instance is waiting at exactly the reserved seats. As for the external task, we don't even need to assert that it's there manually, because BPM Assert does it for us the first time we try to access it. And we're going to see where that is. And this is in the driving part. So let's make this a bit more beautiful here. Have a one-liner to assert that we're at the right place, and then it's fine. So over to all of this code. Very technical, very error-prone. You have to make sure you use the right parameters in the locking and in the completing. It's a nightmare to use in a test. It's a nice API, but not for testing. So let's remove all of that code, because it's just way too complex to use. So what we really want to do is this. We want to complete an external task. So let's just do it. BPM Assert allows us to use static helper methods like complete, for example, in this case expecting an external task. So let's provide the external task. BPM Assert allows us to use another helper method, which is called external task, which just fetches in this case, the single external task of the model, and fetches this into the complete method. In case you would be having, for example, concurrent external tasks running, you could also provide an activity ID, in this case reserved seats, in order to fetch the external task that you want to test on. But in our case, we don't need it. Coming back to variables. As I said, if you're lucky, you know that we have the variables class, which has a put value method, which returns the map, and then you can always put values in a chain fluent way. This is nice, but it can actually be done in an even more efficient way, which is the helper method with variables. It allows you to just paste in a list of key value pairs, so you don't have to call put value methods or put methods on hash maps. You just put in the list of key value pairs and you're done. With that, we get a nice one-liner again to complete the external task with specific variables. It just reads perfectly, it's very understandable, and it's very easy to maintain. And that's actually it. That's all you have to do to drive your external task. You don't have to lock tasks. It's all done by BPM Assert for you. Getting to the assertion, we already saw that we can write assertions on process elements, for example, the process instance, in order to make sure it's, for example, waiting at a specific step. In this case, we want to assert that the instance is waiting at exactly our event-based gateway. And that's actually it. That's all you really have to do if you use the right tools in order to make sure that if you complete an external task, you get past it and the model is driven forward to the next activity. Compared to the code that we saw before, which was kind of, well, nasty. It's a little bit verbose and uses a lot of technical stuff that you have to know, a lot of concepts that you have to know. Fetch and lock is something you have to grasp why you have to do it anyways. And if we abstract from it and use the right tool like BPM Assert and process instance modification in this case, it's a lot easier to read, it's a lot easier to understand, and therefore a lot easier to maintain. So, okay, now we saw that external tasks are pretty easy to use. Okay, fair enough. What about call activities? Let's see how people often do this. And if you find yourself using this code, it's perfectly fine because it's correct code, but it's just very verbose. So the usual thing, people tend to get all the services. We just learned that we don't need to do this, so let's not do it. Then we started a process instance. We know the process instance, the token is created, and it's placed on the start event, and now you have to drive the whole model up to the point that you want to test, which is a nightmare if this is the last activity in your process. So what you would have to do in this case, after you access the statically available method, you would have to do all of this stuff. So you would have to complete the user task that is the first activity. Then you have to get past the external task. So you have to use all of those lovely manual code for external tasks again. Then you have to use message correlation in order to get past the event-based gateway, for example. If you're lucky and you know that you can use the message correlation API, we have seen code where people try to fetch the execution and then signal it, which is a fairly nasty thing because you have to find the right execution that you really want to signal afterwards. So this is a nightmare to use. And afterwards, we still have another user task, and then we're finally at the point where we have this call activity. And as we just learned, we don't want to do any of those things because that's just a very tedious thing to set up tests and test cases, so let's remove it. We learned that process instance modification is a very powerful tool here to set up test cases for processes, so let's use it. So we use the create process instance by key again, and then we instruct it to start exactly before our call activity, and we're there. Nothing more to do. Test setup, done. So that's actually just 3 lines now instead of, I don't know, 10 that it was before, which is a lovely thing because you're not now, now you're not dependent anymore on the model and everything that happened before the activity that you want to test. So to the assumption part, wow, nice, very nice, nice music. So in order to find the process instance that has been spawned by your call activity, you first need to know that now there is the second process instance. So you have your master process instance and the spawned subprocess instance. And in order to find it, you have to know that you can use something like the super process instance ID somehow in the process instance query in order to find your called process instance. And then you can use the query in order to get the instance, which is okay if you know it, but if you have to find out, well, that's a thing you have to do. And actually what we want to do is we just want to have the instance that has been called by our instance. So why don't we just write down exactly that? So we want to have the called instance, so we just tell BPM Assert, give me the called process instance. And since we want to have the called process instance that has been called by our master instance, we feed this in there, and that's it. So it's actually a lot more readable, so you want to have the called process instance of the current instance, and that's it. You have your call process instance. And now you have to drive this one, because what happens now is the same thing with, that happens with start process instance by key. The subprocess instance is created, a token is created, and it's placed on the start event of the subprocess. And what people tend to do a lot of times in test code is use their production model for testing as well. This is fine for the model that you really want to test, which is our super process instance, but you don't want to do this for the subprocess instance because that becomes a nightmare. Now you have to drive this model, or it may be this model, or it may be even this model. Good luck finding the smallest, the shortest path through the model, and then using this in your test and driving forward your model. So maybe you have to do some task completion, maybe again some message correlation. Let's assume that's another call activity. This is going to be fun. So you don't want to do this. So how can we get around it? Sure, process instance modification could be a thing here, but it's actually a lot easier than that. Because what you do, hopefully, with your business methods, so with your service calls, is you use mocking. Use it for processes as well. So use this one, for example. It's fairly easy to test, right? So just in your test code, you could use this as your sub-process model. It has a wait state. That's fine. You want to maybe make sure that the wait state is in your sub-process and that your master instance behaves correctly. So if we use this one right now, we really know what we have to test. It's fairly hard to break this thing. So actually, all we have to do is just complete one task, and we're actually done driving the sub-process. Said and done. The thing with user task is BPM Assert is pretty nice in abbreviating this as well, just as with external tasks. You can use a complete method, and you feed in the task, for example, the user task in this case, and you're done. You want to complete the user task of the called instance. So we maybe feed in the called instance here as well, and then we're done. So now we're completing the task of the called process instance, and that's it. The whole sub-process is driven to its end, and we tested what we want to test, that we have a wait state and a sub-process, and we can move past it. And what we now want to assert is that our called process instance is finished. How do we do it? Well, we have a concept of runtime and history. And since the process instance is finished, it's not present in the runtime anymore. So you have to use a history query for historic process instances, use the process instance ID of your called process instance, make sure it's completed, and make sure it's only one of them. That's a very verbose way of asking or asserting that your called process instance is ended. So why again? We can get rid of all of those things, because what we want to do is we want to assert that our called process instance is completed. And that's all we want to do. In the terms of BPM Assert, it's called is ended, because that's more speaking. So asserting that our call process instance is ended is a lot easier to read, a lot easier to understand, and therefore, of course, a lot easier to maintain. The same thing goes for our master instance, which is now finished as well. And again, you would have to repeat all of this code because it's not very reusable, so it's very repetitive, of course. So as we just saw, we can abbreviate this to just make an assertion on our master instance, which is also ended, and that's actually it. That's all you need to do to get past your call activity, for example. So by using stuff like the process instance modification API, by using BPM Assert to make it easy to complete stuff, and using mocking for sub-processes and process models as well, there's a lot of code reducement we can do. It's, again, a lot easier to maintain. It's very less error-prone to break. So if your sub-process model changes, you don't really care in your process here. At least if it doesn't depend on changing wait states, for example. If you change your sub-process model to only include service tasks without any breaks in there that do transaction breaks, you would have to change your sub-process model, for example, to just use a service task, but that would be it. So there's nothing more you would have to change. Okay, so that's actually, for those two examples, everything I wanted to show what BPM Assert can do for you. To give you, again, a little overview, this is what the code that we used before. So on the left-hand side, you have the external task. On the right-hand side, you have the call activity with all the setup and all the driving the sub-process model. And you can reduce it to something like this, which is, again, way more readable, way more maintainable, and a lot less prone to break. All of the other things that we saw in the first model, they're tested in this example here. So you can go right there, fork it, look into it, download it. You can change it, challenge it, expand the model, whatever you like. See how you can improve the model, for example, or extend it and then improve the tests. Feel free to hack away with it. If you have any issues or requests that we should change something with it or put more examples into it, just let us know. Just open issues there or email us or whatever channel you prefer. And we will happily adjust this to have this as a go-to point to see how to do process testing in an efficient way. So after looking all the examples that we saw and how we improved them, I hope that we can all agree that testing complex processes doesn't have to be a very tedious and repetitive task if you use the right tools. And that actually concludes my talk today, and I guess it's the perfect timing for questions or anything you want to ask. Feel free to raise a hand. We have a mic here, so we'll make sure to get your question answered. Thank you.